In this lab, we'll configure, you guessed it, route reflectors. We have 3 route reflectors, route reflector 1, 2, and 3. Route reflector 3 have 2 route reflector clients, and route reflector 1 and 2 have 3 clients each. If you check this part here, this is the topology that you will see most often, and this topology is used in most of the service provider deployments. So, as I mentioned, BGP route reflectors are just a iBGP configuration with some additional options. So when you set up iBGP, you usually set up the iBGP using the loopback interfaces. So in order to set up iBGP, we'll need that each router knows the loopback address. So what we'll do is configure OSPF on each of the routers so we can share the loopback addresses. If you check the configuration, we have only the interfaces configured on each of the routers. So let's start with RR1. Go with set protocols, OSPF, RS0, interface. RR1 have 4 interfaces, and it is 0, 1, 2, and 3. So G 0.0, G1, 2, and 3. And we'll also add loopback 0.0 as a passive interface and hit commit. Let's check the configuration, and I will just yank this configuration and add it on route reflector 2 and 3. But I'll have to do some modifications on route reflector 2 because it is pairing with route reflector 3 with G04 interface. So I'll just yank this configuration here and add it on route reflector 2, add interface 4 and loopback 0.0 as a passive interface, and that's it. On route reflector 3 we have 0, 1, 3 and 4. So I can get 0 and 1, add it on route reflector 3 and add interface 3 and 4 and loopback 0.0, which is the passive interface, and yes. With the rest, we'll go to the R4, and R4 is pairing with RR1. I mean, R4, R5, R6 is pairing with RR1 with G00 interface, and it is pairing with RR2 with GE001 interface, as you can see. So we'll have to configure the OSPF on these routers by using these interfaces, and I will add these 2 interfaces along with loopback 0 interface, which is passive. And I will just yank this configuration and add it on R5 and R6. Okay, for the R7 and R8, in this case we are using G00, in this case we are using G001. So set protocols OSPF area 0, interface G000.0, and loopback 0.0 as a passive interface and click commit. Here we'll have to add G001 and loopback 0.0 as a passive interface, and I will commit it. And let's go back to RR1 and check the routes. And as you can see, almost every route is shared. And show route. Let's go back here and check if all of them are shared. Okay, so all loopback interfaces are shared. So now we should go ahead and configure our route reflectors. As I said, set protocols BGP group route reflectors will be type internal. We'll add the local address, which will be 1.1.1.1, and the cluster configuration, which is also 1.1.1, and we'll add the neighbors, which are 4.4.4 and 5.5.5 and 6.6.6.6. Also, we'll pair RR1 with RR2. They can share routes between each other. Go ahead and commit, but I cannot commit because I need to define a local autonomous system for all of the devices, and our local IS is 65000. So set routing options, autonomous system 65000. And now I can add what I want. Okay, let's configure R4, R5, and R6. So in order to configure the clients, you just do it the regular way, don't add anything, just regular BGP configuration. Set protocols BGP group clients will be type internal, local address will be 4.4.4, and neighbor will have route reflector 1 and route reflector 2. And basically that's it. Just don't forget to add the autonomous system. Let's check the BGP status. And we should have the first peering up any minute. And as you can see, it is up. Okay, let's go to RR2 and configure the route reflector here. Set protocols BGP group route reflectors, type internal, local address is 2.2.2, which is the loopback address. Cluster ID is also this one, and the neighbors are 4.4.4, 4, 5.5.5, 6.6.6, and what I forgot is to pair RR1 with RR3. I'll do this here this way, add the autonomous system, and I will commit. Let me go back here and let me add also RR3. Okay, let's check the BGP neighbors here, and it is paired with R4 and now with RR2. Okay, so on RR3, again, we'll add the autonomous system, set protocols BGP group route reflectors, type internal, local address 3.3.3, cluster 3.3.3, we have the neighbor 1.1.1.2.2, we'll have 7.7.7, and we'll have all 8s, and I will go ahead and commit it. Run show BGP summary. So note that I will establish BGP on R3 between R7 and R8, RR1 and RR2. The rest of the routers here are the clients of RR1 and RR2, so I don't need to pair them with RR3. Okay, going to R5, set protocols, but before that autonomous system, set protocols BGP group clients, type internal, local address, it's 5.5.5, and neighbors, our route reflectors. Commit and move the party to R6. Commit R7, group clients, type internal, local address, it's all 7s, and the neighbor will be R3 only. Commit autonomous system. Okay, perfect. And let's add autonomous system, set protocols BGP group clients, type internal, local address, it's all 8s, and the neighbor all 3s. Let's check the peerings on each route reflector, and all peerings are up here, and all peerings are up here, and I would expect the same here. Okay, so now we configure the route reflectors, but we are not receiving nor sending any routes on any of the route reflectors. So what we'll do, we'll go on each of the route reflector clients and we'll configure a policy which will share the IP addresses on the interface G002. So set policy options, policy statement, export BGP from interface G002.0, then accept. Actually, I don't know if this will work, but let's try to do that. and export. Let's go on RR1 and see if we are receiving something. And yes, we are receiving run show route. We are receiving this route, and in order to reach for this IP address, which is configured directly on G002 interface, you have two paths. You either go straight to 444, which is preferred, or you can either go to 2.2.2.2. Okay, let's go here and copy this, add this policy to all route reflector clients. And if I go to R4, I will need to take also this one and apply the policy on all route reflector clients. And let's commit. If I go back to route reflector 1 and if I check the BGP summary, I can see that I am receiving a route from run show BGP summary and show interfaces. Maybe I don't have G002 interface configured, but I do, and maybe it wasn't shared yet. Show route. So we are not sending the 55 route to, let's check why. Show route advertising protocol, BGP, and the neighbor. Don't advertise anything. And also we don't advertise anything here. Let's check the configuration. Okay, I found the problem. Export BGP. Go back here and check the route. And we have it. Okay, cool. So now we are sharing the routes between all of the route reflectors, and let's check the routes on R3. See if we are receiving the routes. And yes, indeed we are receiving the routes. And here are the routes. Let's check, for example, this one. Run show route 44.44.44.0 extensive. So we have two routes for two entries for 44, 44, and so on. So we have the cluster ID of the R3, and we have the cluster list, and we see that this route came from 111, and the originator ID is 4.4.4, which is the R4, and this route passed through RR1. Here are the cluster list and the originator ID, and if you check the second route, we'll see a different option here. You see the cluster list, and the originator ID and show route. Let's go on R7 and issue the exact same command and check what we have here. So as we can see, now the cluster list here looks totally different. It originated from 4.4.4.4 and the cluster list is 1.1.1.1 and 3.3.3.3. So it means that it went from route reflector 1 to route reflector 3 and arrived at R7. It's looking a little bit weird because we are used to see the IS numbers listed here, but this is how the route reflectors are advertising where the route was. Because if we go back to route reflector 1 and we check again this route, we can see only 2 entries here. And we don't see an entry from route reflector 3 because when this route arrived to when route reflector 3 tried to advertise this route to route reflector 1, it saw its ID in the cluster list and it just dropped the route and didn't accept it. What we can do now is we can check if the configuration is working. So we're on PC1 and let's try to ping PC5. 55, 55, 55.2, and as we can see the ping is working perfectly. So this is what we tried to achieve and this is what we achieved. We configured the route reflectors, which is not a big deal because the configuration is basically the same. You just add the cluster and basically that's it. Thank you for attending, and I hope this is useful for you, and I hope that you understood how a route reflector operates. Also forgot to mention that if you notice, we don't have any next hop self policy added because the route reflectors are automatically adding the next hop to the routes, so the route can be resolved by the BGP peers. Thank you, and I will see you in the next one. Bye bye. So, on a quick side note, like I said, you can find the video series links in the description and you can watch these videos chronologically. You can also hire me on Fiverr. I offer consulting and design services, troubleshooting and whatnot. And if you want to follow along with my Udemy courses, you will also find the discount codes in the description. Thank you, and I will see you in the next one.